What makes a jet engine so powerful that it can propel a massive plane through the air? And how does it actually work? At its core, a jet engine is like a giant fan, but a supercharged one. Imagine blowing up a balloon and then letting it go. The air rushes out one end, and what happens? The balloon zooms off in the opposite direction. That's the basic principle of how a jet engine works. When a jet engine operates, it draws in a massive amount of air through its front. This air is compressed, which means it gets squished into a smaller space, increasing its pressure and temperature. Think of it like squeezing a sponge filled with water. The tighter you squeeze, the more force that water builds up. Now here's where the magic happens. Once that air is compressed, it mixes with fuel. The engine then ignites this mixture, and the combustion creates a powerful explosion that pushes the air out the back at incredible speeds. This high-speed stream of air creates thrust, which is the force that pushes the aircraft forward. And here's the surprising part. The jet engine doesn't just rely on the exhaust for power. It also uses the air it's sucked in to create lift as the plane moves forward. So it's not just about blowing air backward, it's about working with physics to keep the plane aloft. So, to answer the question, a jet engine is a powerful fan that propels airplanes by compressing air, mixing it with fuel, igniting it, and pushing that air out rapidly. It's a brilliant blend of engineering and physics, making air travel not only possible, but incredibly efficient. What are the main parts of a jet engine? Picture a jet engine as a super efficient, high-tech pipeline. It's designed to take in air, mix it with fuel, ignite it, and then push it out to create thrust. Let's break it down into its four main components: the compressor, combustion chamber, turbine, and nozzle. First up is the compressor. Imagine a giant fan at the front of the engine. As the plane moves forward, this fan draws in a massive amount of air. The compressor then squeezes this air, increasing its pressure and temperature. Think of it like a bicycle pump. As you push down, you're compressing the air inside the pump, making it more powerful. Next, we have the combustion chamber. This is where the magic happens. The high-pressure air from the compressor mixes with fuel, like aviation-grade kerosene, before being ignited. When you light that mixture, it creates a rapid expansion of hot gases. It's not unlike lighting a firework. The initial spark causes a big explosion, pushing everything outward. Now, those hot gases flow into the turbine. The turbine is like a windmill that converts the energy from those gases into mechanical power. As the gases spin the turbine blades, they continue to push through the engine. This stage is crucial because it helps keep the compressor running, creating a self-sustaining cycle. Finally, we reach the nozzle. This is the opening at the back of the engine where the hot gases exit. The nozzle narrows down, accelerating the flow of air. Think of it like squeezing a garden hose. The tighter the nozzle, the faster the water shoots out. This rapid expulsion of gas generates thrust, propelling the aircraft forward. So, to sum it up, a jet engine is powered by its four components: the compressor, which pulls in and compresses air; the combustion chamber, where fuel and air meet and ignite; the turbine, which harnesses energy from the hot gases; and the nozzle, which propels everything out. Each part plays a vital role in making flight possible. How does a jet engine create the thrust that pushes an aircraft forward? Here's the surprising part. It all starts with the compressor. Think of it like using a bicycle pump to inflate a tire. When you pump air into the tire, you're squeezing it into a smaller space, making it denser. The same principle applies here. As the engine draws in air through the front, this compressor spins rapidly. It compresses that incoming air, packing it tightly and increasing its pressure. This denser air is crucial because it allows for more efficient combustion later on. Imagine if you were trying to start a fire with just a few twigs versus tossing in some dry leaves. More air in the mix means a better burn. Once the air is compressed, it moves into the combustion chamber, where it meets fuel, jet fuel, to be exact. Here, something fascinating happens. The high-pressure air mixes with the fuel and is ignited. This creates a high-temperature gas that expands rapidly, like a balloon bursting. As the gas expands, it shoots out of the back of the engine at high speed. This is where the magic of thrust comes into play. According to Newton's third law, for every action, there's an equal and opposite reaction. So, when the engine pushes the gas out, the aircraft is pushed forward with equal force. That's how the jet engine generates thrust. It compresses air, mixes it with fuel, ignites it, and then lets the expanding gases propel the plane forward. Next time you fly, you'll know exactly what's happening under the hood. So, how does that high-temperature gas actually create motion? Picture a bicycle. When you pedal, you generate energy. Now imagine that energy is used to spin the wheels. In a jet engine, the spinning motion comes from the gas expanding through the turbine. Here's how it works. Once the fuel and air mixture has been ignited in the combustion chamber, it creates a high-pressure, high-temperature gas. This gas then flows into the turbine. Think of the turbine like a set of blades in a windmill. As the hot gas rushes past these blades, it causes them to spin. This spinning turbine is crucial because it's connected directly to the compressor at the front of the engine. Now, here's the surprising part. As the turbine spins, it drives the compressor to pull in more air. It's a continuous cycle. The more the turbine spins, the more air the compressor can suck in, which keeps the whole process going. It's like a merry-go-round. Once it gets going, it keeps turning faster and faster. Finally, the gas exits the engine through the nozzle. This nozzle is shaped to allow the gas to speed up as it leaves, much like squeezing a garden hose to increase the flow. When that high-speed gas shoots out the back, it generates a forward force known as thrust, which propels the plane forward. So, to answer our question, the high-temperature gas expands through the turbine, making it spin and drive the compressor, creating a powerful cycle that propels the aircraft. Isn't it fascinating how all these parts work together? If you're curious about more aviation wonders, don't forget to subscribe. And here's the reassuring part. Modern jet engines are incredibly efficient and safe. Think about it like this. When you ride your bike, you want the gears to shift smoothly, right? Jet engines operate in a similar way, but they do it on a much larger scale. They're designed to maximize thrust while using as little fuel as possible. This efficiency not only keeps costs down, but also reduces the environmental impact of flying. But what truly sets jet engines apart is the safety built into their design. They come equipped with multiple redundancies. Imagine a car with two brake systems. If one fails, you've got a backup. Jet engines often have multiple components that ensure they can still function, even if there's a malfunction in one part. For example, if one fuel pump has an issue, the engine can still draw fuel from another pump. Plus, these engines are rigorously tested to handle extreme conditions. They experience temperatures that can exceed 1,500 degrees Fahrenheit, yet the materials used are specially engineered to withstand that heat and the tremendous forces at play. The turbine blades, for instance, are made from superalloys that maintain strength even under stress. This means that while the engine is working hard, it's doing so safely, with engineers ensuring that everything is in tip-top shape before each flight. So, while it might seem complex, modern jet engines are designed for efficiency and safety, making flying an incredibly secure mode of transportation. Next time you take off, remember all those layers of engineering working to keep you safe and sound in the sky. So, to answer our initial question, how does a jet engine really work? It's all about three key processes: air compression, fuel ignition, and gas expansion. Imagine a giant air pump. This is the compressor. It draws in air and squeezes it tightly, increasing its pressure and temperature. Next comes the ignition chamber, where the magic happens. Here, we inject fuel into that high-pressure air and ignite it. This creates a rapid expansion of gases, like when you release air from a balloon, but much more powerful. These hot gases rush out of the engine at high speed. And here's the surprising part. As they jet out the back, they push the plane forward thanks to Newton's third law. For every action, there's an equal and opposite reaction. This entire process is a remarkable feat of engineering that allows us to travel across vast distances quickly and efficiently. It's one of the reasons flying is incredibly safe, with rigorous safety checks and standards in place. Now you know the basics of how a jet engine works. The next time you see a plane soaring overhead, you'll have a better appreciation for the complex machinery that makes it all possible. If you're curious about more aviation secrets, you know what to do. Subscribe for regular explainer videos.